Jai Hind. Hello cadets. In continuation with our discussion about refraction of light, let us now consider those quantities which change or do not change as a result of refraction. Okay. So, a quick recap. What is refraction of light? It is the change in speed as a result of change in medium. Okay. That means whenever light travels from one medium to another medium, so there is change in speed of light. Okay. There is change in speed of light. Second important thing, the wavelength of light also changes. Okay. Because the speed is given as frequency multiplied by wavelength. Now during refraction, speed changes and wavelength also changes, but frequency remains the same. So during refraction of light, there is no change in frequency. Why? Because the frequency of any wave is the property of its source. So if you really want to change the frequency of light, you have to change the source of light directly. So change in medium causes change in speed and change in wavelength. So how exactly can we write that equation? Now if you remember, the refractive index of second medium with respect to first medium, we have seen that it is equal to C1 upon C2. Then it would also be equal to lambda 1 upon lambda 2, where lambda 1 is the wavelength of light in medium 1, lambda 2 is the wavelength of light in medium 2. So whenever light travels from one medium to another medium, the speed changes, the wavelength changes, the frequency does not change. Another important point is the color of any light, any shade of light is dependent on the frequency. The color depends on frequency. That is why if you consider a beam of red light traveling from say air to glass or glass to air, it will appear to be red in color only. It will not appear of different color. So why? Because the color depends on frequency, and because during refraction frequency is constant. Okay, that is why you observe a beam of red light from water or from air, from both the medium, it will appear to be red in color. Okay. Another important point about light, what changes during refraction is the direction of travel. And this is where deviation, the phenomena of deviation comes into picture. So always remember that deviation and refraction are not one and the same. Another important point, deviation is simply change in the direction of travel of the ray of light. Deviation may occur as a result of reflection or refraction. Okay, the change in speed occurs only and only during refraction of light. During reflection, there is no change in speed of light. So deviation is simply the change in the direction of travel of a ray of light. So let us go into the details of this phenomena of deviation and angle of deviation, its measurement, and how to draw or find angle of deviation in a particular case. So consider any ray of light which is traveling from a rarer medium to denser medium. So this is the incident ray. This angle is angle of incidence. This line is the normal. Now this is the original direction of travel of the ray of light. You can see the dotted line. The dotted line indicates the original direction of travel of this ray of light. Now, as the ray of light is traveling from rarer medium to denser medium, it bends towards the normal. So it bends towards the normal in this direction. If you keep this sense, it has rotated clockwise. This angle is angle of refraction. This is the refracted ray. So when the ray of light travels from rarer medium to denser medium, it bends towards the normal. Now, it has bent towards the normal as a result of refraction. So, consider this, that this entire angle here is angle of incidence. Out of this angle is R. This angle here will be equal to I minus R. Okay. Now, next, let's bring in concept of deviation. So, the ray of light original direction was this. So, if this medium would have been absent, this ray would have traveled straight following this direction. But because of the refraction of this medium, because of the change in speed of light due to refraction, the ray of light has bent through this much angle. Therefore, this angle here denoted by delta is the angle of deviation in this case. So, how can we possibly define angle of deviation? The angle through which a ray of light has been deviated from its original direction. So, this ray, originally it was going like this. Because of refraction, it got deviated through this much angle. So, exactly this much angle would be the angle of deviation, and by the geometry of the figure, that angle would be I minus R. So, we can generalize this also, that if a ray of light is going from rarer medium to denser medium, first, delta is going to be equal to I minus R. Second, I will always be greater than R. So, if a ray of light is going from rarer medium to denser medium, I will be greater than R. Delta, angle of deviation, will be equal to I minus R. Now, if you want, you can pause the video at any point of time and you can view this diagram in detail. Okay. Now, the second case that we are going to consider is the ray of light traveling from denser medium to rarer medium. So, suppose this is a denser medium and this is a rarer medium. A ray of light is incident here on the boundary of these two media. Once again, this is original direction of travel of the incident ray. Now the ray of light is traveling from denser medium to rarer medium. So, we know the concept, we know the principle. Whenever a ray of light travels from denser medium to rarer medium, it moves or bends away from the normal. So, here this angle would be angle of refraction. Now, let's go back to deviation once again. This is the original direction of travel of the ray of light. This is the final direction. That means as a result of refraction, it got deviated through this much angle. In this case, therefore, this is angle delta, the angle of deviation. And by the geometry of the diagram, observe, this entire angle is R. Out of that, this angle is I. So, delta will be equal to R minus I. So, whenever a ray of light is traveling from denser medium to rarer medium, another observation we can make, R will be greater than I and delta, angle of deviation, therefore will be equal to R minus I, because through this angle, this ray of light got deviated from its original direction. Okay. So, that is how we can determine deviation in any case of refraction. Again, what we have to do? First, you have to consider direction of incident ray. Next, you have to consider the direction of the refracted ray. Then you have to see through what angle and in which direction. Through what angle and in which direction the ray of light has suffered deviation. The ray of light has suffered change in direction of travel. Now, there is one more special case where there is refraction, but there is no deviation produced. So, imagine that this is a rarer medium, this is denser medium, but in fact, you can consider this as denser medium and this is rarer medium also. Still, whatever principles we are going to state now, they are going to remain just the way they are. So, suppose this is the incident ray. Now, this ray is incident normally on the refracting surface. Therefore, after a refraction, it will continue to travel in its original direction. This case is a special case called as the condition of normal incidence. So, whenever a ray of light is incident normally on any refracting surface, it does not suffer any deviation. So, for that matter, listen carefully now, this ray of light here is undergoing refraction, but it does not suffer any deviation, which means that here refraction is occurring, but deviation is not occurring. We always treat this as a special case, and we usually do not apply any formula to this case, especially formulas like Snell's law and everything, because here angle of incidence is 0, angle of refraction is also 0, and therefore deviation is also 0. So, once again remember, in this example, there is a refraction taking place, but there is no deviation occurring. So, there is refraction, but no deviation. So, we call it the special case of normal incidence. Okay? All right. That is all. Thank you.